Here we go. Let's find the limit by cancellation. In this one, we're going to utilize our factoring methods because looking at this first one, if I were to plug in 3, well, we definitely would get 3, or we could get 0 in the denominator, and 3 squared is 9, minus 3 is 6, minus 6 is 0. So what this one becomes is it would be 0 over 0. And that is called an indeterminate form. So if you get an indeterminate form, if you get 0 over 0, you should definitely try some sort of cancellation before you move to maybe making a table. So looking at this one, this becomes the limit as x approaches 3 of x minus 3x plus 2, right? Multiplies to give me negative 6, adds to give me negative 1, and then over x minus 3. And what do you know? Right away, you can see that we have a x minus 3 in the numerator, got an x minus 3 in the denominator, so we can chop chop, and this limit is the same as find the limit as x approaches 3 of 1 over x, whoa, got rid of the fraction, equal to the limit of x plus 2. There we go. Now we can plug in 3. 3 plus 2 equals 5, and there's our limit. Right? We have a removable discontinuity, so when we remove it, we can still see where the function's approaching. We won't ever hit that spot, 3, 5, but that's where it's approaching. That's where it's getting really close to. So let's take a look at this next one. We have to factor this one as well. So the numerator, maybe do a little factor by grouping. I did it ahead of time. So this is going to be the same as 2x plus 1 times x minus 1 over. And then multiplies to give me negative 7, adds to give me 6, x minus 1, x plus 7. And what do you know? Removable discontinuity again, right? I forgot to mention it, but yeah, if we were to plug in 1 here, we would also have gotten a 0 over 0 indeterminate form. All right, we can remove those negative x minus 1s now. We no longer have a problem. So the limit as x approaches 1 of 2x plus 1 over x plus 7. Now we can just plug in 1, no problem. 2 times 1 plus 1 equals 3 over 1 plus 7 equals 8. And we have our limit.